better than left-hand and right-hand in every case that I could think of, unless it was just a flat function. Um, and not, we'll talk about midpoint a little today. But the idea is that the trapezoids all run parallel, going up and down. And so the height of the trapezoids is delta x, and in this case, delta x was 1. Yes? When they're equal subdivisions, you can factor the height out because they all have the same delta x, so that can be factored out, but in some problems you can't. We'll talk about that today. You can also factor out the half. That half is there because it's part of the formula for area of the trapezoid. Base 1 plus base 2 times height divided by 2. So we're factoring the times height divided by 2 out for all, and doing a little combining like terms to get the inside. So did you get something like 101 over 2 for your estimate? Do you also have that it's an estimate, an approximation? That's not the true area under the curve. You're approximating it, and good math says you should show I'm approximating the area under the curve, right? Okay, B. B says that what makes for trapezoids over or underestimating is not about increasing, decreasing, but about concave up, concave down. If you use trapezoids on a concave up function, the trapezoids will lie above the curve and overestimate. If you use trapezoids on a concave down function, the trapezoids will lie under and underestimate. So the only way we talk about concavity is if we get into the sign of the second derivative. So if the first derivative is negative 4x cubed and the second derivative is negative 12x squared, that is negative or 0 at the very worst case. It's always going to be negative, yeah? So because that's less than 0, f is concave down. I give myself a little doodle. If I had a concave down curve, the trapezoids will underestimate, yeah? All right, so the true value should be greater than 101 over 2, where estimate of 101 over 2 should be is less than the true value. All right, so now they say, all right, well, let's verify that. If you integrate that either by hand or by calculator, what did you get for the the evaluation of the integral? 53.4. Now that's exact. 53.4 is exactly the area under the curve. Now this approximation was 50.5. So does this verify or does this ring true then? Our estimate is less than the true?
Yes.
We're all good. 50.5 isn't too far off. How could we make it better? Smaller subintervals and more trapezoids. The more you subdivide it, that's true for rectangles too. The more you subdivide it, the less error you get. So if you increase the number of trapezoids, you get less and less error. Let's go to some of today's stuff. All right, so I'm going to do a little jumping back and forth between the notes, which I didn't cover all of, and a little bit of tonight's homework. We'll do a little here and there. All right, so I'm on the bottom of the front of the notes. Do you see where I'm at?
Yes.
All right, it is sometimes the case that you don't have equal subdivisions on 20 minus x to the 4th from negative 1 to 2. Why not use equal subdivisions? All right, but if you are doing sine of x, which I know can be integrated, but stick with me, from 0 to pi over 2, and you are using 4 subdivisions, if you subdivided that equally, then what is each subdivision? Okay, from 0 to pi over 2 divided into 4 equal chunks is pi over 8. Do you know the sign of pi over 8? You don't. Neither do I. Okay, so instead, if you were going to do 4, you could instead do nicer points. You could go from 0 to pi over 6, then pi over 6 to pi over 4, then pi over 4 to pi over 3, then pi over 3 to pi over 2. Now, those are not equal subdivisions, but they are values you know. So it is sometimes the case that you want to use unequal subdivisions because the function's cleaner at different values than the equal subdivision cases. Think of also the square root. If I were finding the square area under the square root function from 0 to 36, I wouldn't go by nines, because while I know the square root of 9, I don't know the square root of 18. I don't know the square root of 27. I instead might go the clean spots like 25 and 16 and 9 and 4. And they would be unequal trapezoids. You with me? All right. Sometimes you're also given data that's not collected in equal subintervals. For here, for example, you can see that one interval is 2, then this is 2, but then this jumps by 4, and this is by 3. So these are not equal subdivisions. Now what I wrote over here in the box then means if they're not equal subdivisions, then these heights are not equal. You can't factor it out because it's not a common factor. In that case, then that whole idea of factoring out a height over 2 and f plus 2f and all that, out the window. You can't do it. Okay? So instead, you actually have to do multiple trapezoid calculations. So, as an example, say here, I gave you this and I wanted you to approximate the area from 1 to 12 under f. You would do 1, 2, 3, 4 trapezoids, which they tell you to use. But the first trapezoid would be the height is delta x. So what is the first height of the trapezoid? 2. Okay, it's that. Remember, although it's horizontal, that's actually the height. The bases are the parallels, and they run up and down. So the bases are f at 1 and f at 3, so 4 and 10. That is its own trapezoid we'd have to do. Then we would add that to the second trapezoid. What are the bases, and what is the height for the second trapezoid? 10 plus 14 for the bases or the parallels, and the height is 2. The next trapezoid, what are the bases? 14 and 11 times height of 4 divided by 2. And the last trapezoid, what are the parallels or the bases? 11 and 7. You can see we're just using the table back and going up each time. And the height, 3 divided by 2. All right. After that, be wise with your arithmetic. The first one, the 2's hack, and you get 14. The next one, 2's hack away, you get 24. The next one, you can maybe divide by a factor of 2, and you get 25 times 2, which is 50. And the last one, I think I would probably, 2 doesn't go into 3 well, but it will go into 18 well. So if you add first, get 18, divide by 2 for 9, and 9 times 3 is 27. Therefore, the area under the curve estimate is, just in group swell, 38, 88, what, about 115? Okay. Are you with me? All right. Would you then practice that on this bad boy with, should we do an easy one or a hard one? Okay, we'll do one easy one and one hard one. Would you do number 4 on the front side of this extra practice, please? This is the easy. Do number 4 on the front of the extra practice. All right, how are we doing? Are we getting 79.5? You guys really slow. Okay, poodle. Should we try a harder one? Or not? Let's go with. That's ready. What's the problem? Check each of your results for each trapezoid. See if you have an error, which trapezoid you made an error on. Let's go with. Try 6, please. Six. Now we could all get slightly different answers here depending on what you eyeballed. Oh, these are equal subintervals, darn it. This is not new, is it? Maybe I should have had you try. That's not new. Darn it. Well, is it too late? Are you already going? Should I leave you alone or?
Yeah.
Okay. So you could do this by equal trapezoids, but here because they're equal subintervals, could you do the height divided by 2 factored out kind of idea too? You could. So I think it's probably less work if you do. The height is 1. If I'm dividing a region of 8, it's 8 parts divided by 2. So 1 plus 2 times 1.5. Yeah, estimate, we can be slightly off, no big deal. 2fx. I'm getting 20. What do you get, Matt? You got about the same thing. Are we all in the ballpark of 20, give or take maybe 1 or 2 units?
Yeah.
Square units. Okay. Okie dokie. Going back to the notes, sorry. There was one thing I wanted to tack on to the, is it an over or underestimate, okay? Now this goes to idea, I don't know if you have room on the notes to tack this on off to the side, but would you draw 2 or sketch 2 identical concave up curves. Something like this. Here, the best you can, all right? Now, if you were to use trapezoids, here, T stands for a trapezoidal estimate. Let's use just one trapezoid. You follow? Now, I think we can see that because it's concave up, the trapezoid would overestimate. All right, now, there's this awesome fact that makes for a really small error if you close a window around it here. What about midpoint? M stands for midpoint rectangles, all right? Now, to remind you of the midpoint rectangle idea, that's usually the most accurate, even more accurate than trapezoids. So the idea is you find the middle x value, which is roughly here, right? You with me? You go up to the curve, and midpoint are rectangles. So if we did one rectangle, then you would use the height at the middle x value. Now, in terms of over or underestimate, you can see it's a little under or overestimating there, but on this side it's a little under. You with me? All right, so trapezoids are an overestimate. Now, the net result, though, what do you think? Would the midpoint be a little more or a little less than the true value? This is an overestimate, this is an underestimate, but overall the underestimate or the error here is a little greater than that error. So M will underestimate a little. You with me? But it's a little less error than a trapezoid. So it seems like they have opposite errors here. Trapezoid is an overestimate. Midpoint is an underestimate when it's concave up. Now draw a concave down curve, something like this and this. Try and make it the same. And let's do a T-estimate or a trapezoid estimate. I think you'll agree that the trapezoids will underestimate the area under that curve. Now draw a midpoint. Here's the middle of the x interval is here. Go up to the curve, draw a straight line over, and let's talk about the shading here. Now in this case, it feels like the overestimate area. In this place, the midpoint line is greater than it should be, so we're overestimating here, underestimating there. But is the net result a little more overestimating or a little less overestimating? I didn't know to say that right, but is it overestimating or underestimating? It's overestimating a little. All right. Now, again, I told you yesterday we don't do Simpson's rule in this for the AP test, but most colleges do, and I let you understand where it's coming from, all right? The best estimator when you can't integrate is what's called Simpson's rule, and it uses a blend of these two. It uses the fact that the true error is between the two, so averaging them is a good estimator. But midpoint is a little better, so they favor or weight the midpoint estimate. So Simpson's rule is a weighted average of the midpoint rule twice and the trapezoid rule once. And you get a really, really good estimate there, all right? The point you need to understand, though, is that the true area is between the trapezoid and the midpoint if it's concave down, then the trapezoids are underestimating and the midpoint's overestimating. And on a case where it's concave up, the trapezoids are greater than the true area, and midpoints are a little less than the true area if it's concave up. Okay? With that said, would you do on the back 1, A and B? It's towards the top of the page, it's the third problem down. If you don't understand my sequence in 6, 7, 1. Yeah. Nope. Can I add a little something on A? Yes, you need it. 1.2. Don't you need it? 1.6, 1.2, 0.7, 0.4. No, it's good. Never mind. You're good. Never mind. It's good. It's what I wanted. What did you think of the first question? This is a pretty common concept on the AP multiple choice. Okay, let's go here. Second derivative. Give me one way to think of the second derivative. Oh, beautiful. Change in the change. Okay, it is concavity, but it's also change in the change. So isn't the change here a positive 1.6, then a positive 1.2, then a positive 0.7, then a positive 0.4, then a positive 0.1, then a negative 0.4. So what's the change in the change? Is the change increasing or decreasing? The change is decreasing, so what does that imply about F double? Is negative. So F is concave down. All right, now the question should be better. That's the answer to A, yeah? Change is decreasing, so F double is negative, or you could say F prime is decreasing, so F double is negative. Based on the fact that it's concave down, then, is the true area, which I'll call the integral, which is going to be above and which is below. If it's concave down, will trapezoids over or underestimate? Under. So the true area would be greater than the trapezoid estimate, but it would be less than the midpoint. Remember, the midpoint and trapezoid estimate or overestimate in opposite ways. All right? Last but not least. This is a humdinger. Okay, check this out then. If you ever estimate in math, then the beauty that you sometimes have after that is, can you figure out how much error or how bad or good your estimate is? Not everything has a measure of, you can expect this much error or not, but trapezoids are one. You have an error bound, right? So say you're estimating an area under the curve. What would go into how much error if you use trapezoids? What are 3 factors that would contribute to error in using trapezoids? Number of trapezoids, wonderful, okay. We know that that's a relationship of the more trapezoids, the less error, and the less trapezoids, the more error. That's an inverse relationship, okay. What is another? These other 2 are less obvious. Okay, so imagine this, the scale of this region was from 0 to 0.2. And I looked at the error. Numerically, would this be a big number or a small number for the error? A small number. Now imagine if it was from 0 to 100 million. or a million, or whatever this number is going to be. Is that number a big number or small? Big. Okay, so the other case is the error is directly related to the magnitude of the region, or how big the region is. All right. The last one. Imagine two concave up curves. Now, we don't talk about degree of concavity much, but imagine a curve was really concave up versus a curve was a little concave up. Which one has more error? The top one. Okay, so the third is how much concavity, or how concave it is. Now, all those three things then, in a way that the formula comes from a rather complicated MDT calculation or proof, so I'm not going to make you sit through the proof, partially because I don't remember it, quite frankly. But the idea is here. The error in calculating the estimate of an integral is less than, not equal to, okay? It drives me crazy when people say the error is this. Well, that's ridiculous. If I knew how much the error was, then what would I know? I'd actually know the exact. So what am I estimating at all? It's not you're finding the error. You don't know the error. You know the error is less than, has to be at most this, okay? It's an error bound, not error. It's a bound for the error. The error is not more than this, okay? Now, the error is bound by three concepts here, all right? The error is contributed to or bound by B minus A. Now, that's a measure of how big the region is. When you take B minus A, that's a measure. Is this talking millions or hundreds? Is this region small or big? N is the number of trapezoids. Now that's in the denominator because that's an inverse relationship. The greater the n, the less the error, and the more the n, the less the n, the more the error, right? So that's in the denominator, logically speaking. And M is a measure of the concavity. This actually has lots of different, anytime I take the second derivative at a point, it's a numerical measure of how fast the slope is changing at that point. M is really just the greatest possible concavity measure in the interval, right? So it's a logical upper bound or the maximum value of the second derivative on the interval. Let's take a look at this here. So if I said use three bounds, three trapezoids, and we'll go equal subdivisions to estimate this. That's old. We did that yesterday. But then we'll find the error bound for this, all right? So if you would, crank out the estimate first, and then we'll do the error bound together. I'm getting 45 over 2. How about you? Okay. All right. That's with equal subdivision, so I'm using the old factoring Avogadro's common factor double method. All right. An error bound then. The error in that estimate, surely because this is curving, our trapezoids are not perfectly area under the curve, there's some error there. The error is not more than B minus A. What is B minus A for this problem? 3 minus 0 cubed over 12. What is n for this problem? 3, which needs to square over. Now, why the cube, why the 12, why the square? That's a little more complicated. Now, m, we're going to need to go off to the side and find m. M is either a max or an upper bound for the second derivative on the interval from where we're going here. So if f is x cubed, and f prime is 3x squared, and f double is 6x. The max of that, now please keep in mind that that's the max of the absolute value. This should be of absolute value of f double. Sorry, it's the greatest possible concavity, whether it be concave up or concave down. Sorry, I forgot to change that in my notes. So you make sure that that's the max of the absolute value. So the greatest possible value in terms of sign. Now, if it's on 0 to 3, where would the greatest possible value of this 6x be? At 3, right? So if 3 goes in, then the max of f double on 0 to 3 is 18. That's in. It's a measure of the greatest possible concavity, which would be the result of then curving away from the line that we're using trapezoids for. So if I clean this up, then the error is less than or equal to, I'm going to just think of it this way myself. I think of all those 3's and saying, and I can take a 6 out of those babies. And so I get the error is less than or equal to 9.5. Okay? Now that actually, in some calc textbooks for colleges, they would say give a range of possible values for the estimate. If they asked you for a range, if you were at that kind of school, that's a pretty rigorous question. Give me a range of possible values for the true area then. Do you understand my question? Okay. So give me something. Okay, what's an upper bound? 27. 45 halves plus 9 halves is 27. Good deal. Give me a lower bound. And now it would be logical to say 36 over 2, 18. Why is 45 over 2 a better lower bound? Because this is concave up, it's got to be an overestimate. So I really couldn't say it's probably 9 halves below. That error is really on the upper side. And so I would probably go 45 halves for my minimum. But in the text, they would probably ask for you to get 18 word correctly. Okay? All right, Mr. Fulton? Right. Okay. Last but not least, sometimes, and this is more of a science application, sometimes you need the error to be less than this benchmark, all right? And so they might say, I need precision in this calculation so that you're within 1,000th away. Well, if they need that much precision, then you're going to need to do more trapezoids. The question is, how many more trapezoids? You don't need to do more than you need. So it's sometimes the case that you start with the error bound, then do the estimate. If the case is such that the error needs to be less than 10 to the negative third, well, let's think of that this way. Let's put the error bound in there. If the error is less than the error bound, and the error bound's less than 1 over 1,000, then surely, if the error bound's less than 1,000, then the error's got to be less than 1,000th as well, right? Would you agree? If I could find an error bound that's less, then the error would be less as well. All right. Now then, if I go to focus on this part of it, this is 3 minus 0 cubed. It's the same region, so we're going to use that same m value of 18, I think it was. Is that right? Okay. 18. What needs to be determined is how many trapezoids to get this error here. So I need to find n. Now, thankfully, we're dealing with all positives. Remember, when there's inequalities, you should be careful, because when you multiply by positives, no change in the sign. But if you multiply by negatives, you switch the sign. So you should always be wary on inequalities. But in this case, you never have negative 2 trapezoids. That's ridiculous. And it's squared anyway, so it's no matter. So the quickest way to get over this is to just multiply n squared over here and the 1,000 over here. And so you have 3 times 3 times 3 times 18 times 1,000, all in the numerator, and 12 in the denominator. You follow me? Okay. If you take out a 6, and I don't know. So what do we got there? 81, 3 times, that's 9 times 9 times 1,000. So that's 81,000 over 2. What's 81,000 over 2? 40,500. We then need to square root that. Square root of 40,500 is what? The square root of 405 times 10. So about 2,200 or so. What are we looking at here? Will somebody throw that in your calculator? 200-ish, 201.246. Okay, now obviously n represents a number of trapezoids. So it would be stupid to say you need 201.246 trapezoids. Do I round to the nearest or do I have to round up? You have to round up. 201 would get too much error, so you always round up, not down. And so you would need, at minimum, at least 202 trapezoids to get the error under that threshold. Understood? Okay. That is from something else, so never mind that. Okay, with that then, we might have to go back and do the error bound on last night's homework for the one in the back, right? There's a signed one or something like that? There's another one as well? Okay, so let's do those two. And we're good to go. Okay. Let me get this out. So look at 12 first. 12 is 0 to pi over 2 sine of x. Okay, it says use unequal subdivisions. Now because you're doing this without a calculator, you don't want to divide it up equally. As we talked about earlier, we're going to use the reference angles here as a guide. It might help for me to put right under these the common denomination between all the answers, which is 12s, right? So this is 2 pi over 12. This is 3 pi over 12, 4 pi over 12, and 6 pi over 12. All right, so the first trapezoid, what's the height? Pi over 6, okay, so this is pi over 6 wide, and base 1 and base 2 are sine at 0 and sine of pi over 6. What's sine at 0? 0, and what's sine of pi over 6? 1/2. Okay, there's one trapezoid. The next one, the height goes from pi over 6 to pi over 4, which is 2 pi over 12 to 3 pi over 12. So pi over 12 for the height, right? The heights are sine of pi over 6 for base 1, or bases, excuse me. Base 1 is sine of pi over 6, which is 1/2, and sine of pi over 4, which is 2 over 2. Okay? The third trapezoid, is what height? It's from 3 pi over 12 to 4 pi over 12, so 1 pi over 12. The bases, our base 1 is sine at pi over 4, which is, and sine at pi over 3, which is root 3 over 2, all that divided by 2 via the trapezoid formula. And last but not least, what's the height? 2 pi over 12 or pi over 6. The bases are sine at pi over 3, which is root 3 over 2, and sine at pi over 2, which is 1. Okay, you don't need to just leave it like that. Okay, you with me? All right. Now, the second part of that question is give an error bound. Now, this one's going to, that's fine. All right. So let's go here. The error is less than or equal to b minus a cubed over 12n squared times m. You do not have to memorize this equation. I will give it to you. I'm not big on memorization anyway, but you'll be given that on any test. Okay. Now in this case, what is b minus a? Pi over 2 minus 0. That's cubed. Over what is n? 4. Now that doesn't matter that it's not equal subdivisions here. We'll play with it. Usually you use this formula on equal subdivisions, but we'll roll with it. All right, now m. Finding m requires work off to the side. What is the function? Sine of x. What's f prime? Cosine of x. And what's f double? Negative sine of x. What is therefore the max of the absolute value of that on 0 to pi over 2? It's at pi over 2, and the value is 1. Okay, so m is 1. It's pretty common on sine and cosine that if you have anything on sine and cosine, you didn't even do all this. You just say, the max is going to be 1. But we'll get into we'll play around with that more later. Therefore, the error is less than whatever that is. That's good. You with me? Does that make sense? What was the other one? Anybody remember?
Number 6.
6? Okay. You can leave it over here. I don't. 6. So, on number 6, did the parts you learned yesterday go okay? I'm sure the exact area under the curve was fine, yeah? A was okay. B, A was a trapezoid estimate with n equal 4. B was the exact. C is probably the new stuff. So let's talk about max possible error. The error bound. The error must be less than or equal to, what is b minus a? 3 cubed over 12. What is n?
Good morning, Dublin Jaguars. Please rise for the pledge of allegiance. Please begin. I pledge allegiance to the flag of the United States of America and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all.
So what's m? 2. So the error is less than whatever that is. Okay? D then is how many number of trapezoids required?
Attention all 8 through 11th graders. This Thursday, CARE is hosting an informational meeting in the cafeteria during 7th hour. No sign-up is required. Simply bring your friends, have some food, and see if cheerleading is something you are interested in.
Okay. So you want the error bound to be less than 1,000, ensuring then that the error is less than 1,000. Right? Your goal is to put in everything but n and find n.
Attention art students.
The top's the same, the m is the same.
Due to the due snow days, you have 2 more days in which you can pick up your pieces. So please pick up your word art sculptures from the library by this afternoon, or they will be discarded.
Okay, so in terms of isolating n squared, it'd be
Don't miss April 10th at 6 p.m. at Dublin. Jill Oppenheimer, certified education planner, will outline how to go into your college planning for next year and reduce your stress. Learn how to best create your college list and how to best navigate the college admissions process.
so I'm feeling something like n squared is greater than 4,500, yeah?
Today is the last day
So
for
n
the
squared,
SAT test
n
prep
is
class,
greater
which will be held in
than
room E100 and not the library.
45. So I'm feeling maybe 65, 70 factoids, something like that. 67, darn it. 67.
DEF scholarships are due to counseling Wednesday after spring break, April 3rd by 3 p.m. Make sure you have all your teacher recommendation forms and the
Okay.
music essay with reference. Any questions, stop by counseling.
Other questions? 1 through,
New Ansberg Scholarship worth up to $9,000
I thought you said 1 through 19.
students pursuing degrees.
1, 3, and 19. And 2?
Dazzling Dad, our girls soccer team is not too much following a 3-0 win last night over the Guitarist Warriors at the St. Louis Cardinals. Honest Colon scored 2 goals and Kane Bridgie was for the Jacks. There were no assists in this game, nor were there any shots on our goal. Thanks to our scoring Jaguar defense. The girls will play their next game on Tuesday, April 2nd against Battle Mountain at El Paso. Go Jacks.
Okay, so how did you find the lateral surface area in terms of RE? Okay, well you definitely know by Pythagorean theorem it's this, yeah? Do you agree? Problem is it says in terms of R only, so that obviously needs to be worked a little bit. The fact that volume is 1/3 pi r squared h allows you to say that h is 3,000 over pi r squared. Do you agree? So L is the square root of r squared plus 3,000 over pi r squared squared. Should we clean that up or let it go? That is an ugly derivative to take. Are you with? Are you right? Am I right? L is, geez, so r squared. Okay, so this you would multiply by pi. Oops, darn it. Have a nice day. Oh, baby. This is getting gross fast. Oh, Corey, okay. Yes, you can use your calculator if you wish. Ooh. Come on. I'll do those. All right, I'll try and get those on later. Have a lovely day. $7 always open too. All right. What a nice lady that is. No, boo. Boo. Just gonna visit somewhere?
Yeah.
So Rickman, are you putting those up on your website?
I guess.
You're out of luck with that list. Thank you.
Tomorrow?
Yeah, I did it late.
Oh, I just assumed you'd be bugging up to the spring break, so it's 6. Okay, I don't have a copy, I'm sorry. Okay, that's good. See you Thursday. Hello, people.
Have you made the PTA for Friday yet?
Yeah. Have you?
Can I have a copy of it for since I'm gone Friday?
Oh, I suppose. Are you taking the test early or late?
I can do it Thursday, 7th hour.
10-4, good buddy. All right.